All right, welcome to part 12 of our Loopstation tutorial. This one seems to just go on and on. There's a lot of things we're learning and want to accomplish anyway, so I'll just keep going until it's complete. So last time we made some buttons so that we can record and play. And the reason we did that is so we can actually grab bits of our waveform in processing there in our GUI, grab bits of our waveform and then loop those. Okay, so it's been a while since we looked at the Supercollider bit of this project. So let's go back and look at it and sort of go over some of the things that are going to be integral to this part now that we want to do the looping. We're going to have to go back here and work it out so that we can loop just one little section of the buffer. Okay, so just as a kind of a review, right? We're recording into these tracks, right? TRX represents an array here of buffers, and that's going to based on this number of tracks, right? So we've allocated x number of buffers, and we have a little calculation that gives us the number of seconds to allocate based on beats per minute and total beats for the track, etc. These are one buffer per track. So we have 8 tracks in this case, and we can have as many as we want within reason, depending on how fast our processor is and how much memory we have. All right, and so just know that when we record and play into our buffers, we're using these buff write and buff read objects, right? Buff read and buff write. Okay, so when we're writing into it, we write to the buffer that is one of those TRX tracks buffers. Okay, and then this, just remember that this buffer write and buffer read, they're both the same, is an indexed object. So it's indexed from some source independent from it. In other words, it needs to be it has a little motor that needs to move it on, right? Okay, so it's going to write every sample, every sample period. It's going to write some kind of audio into this buffer at this point. Okay, so this thing has to move at an audio rate through, if we want to get one sample per slot, right? It's got to move through the buffer, through the slot at the right rate. Okay, and so what one of the sort of things that I wanted to do is have that controlled externally, so we can do syncing across the board. Record, play, sync the cursor in the GUI, sync other things that will be important, right? So we created this whole other buff index synth that's based on this phaser object, which just goes at an audio rate from 0 to 1. Okay, and then just pops it out one of these buses. It pops it out to an audio bus and then an index bus, right? So this is all review, so I'm going a bit quick. And going back to our buffer play and a buffer record objects, we declare a IDX, a bus to read from, and then we'll pop that whatever the information that we're reading from that bus is going to be popped into here. So basically, it's just a one level abstracted, one level removed. That this phaser normally you just stick the phaser object directly in there, but since I want one phaser to stand for everything, and that you can access externally, so we're popping it in through one of these buses. Okay, and bus is just like this patch bay. It holds both audio or control information. It's just a patching mechanism. That's it's just an architecture within Supercollider that works. So this buffer index, this synth, once we make a synth out of it, sends that phaser object, its signal out to an audio bus and then a control version of that as well. Okay, and this is just a normalized version of that bus. Okay, so the audio one we keep at it's 0 to 1 anyways. We keep this is no, I'm sorry, it's not 0 to 1. A phaser is going to run through the buffer, but this one we normalize from 0 to 1. The control one, so that we can use it, say, in the GUI or in other contexts. But this helps to just keep it at the length of the buffer, so it runs through every frame in the buffer, every sample in the buffer, right? And then it sends it to this bus, and we pick it up from the bus and we pop it in here, all right? Now, looking back at our things, we understand that that's our buffers that's holding our audio. Okay, but we have just two buses, and we just have one index and one bus. I'm sorry. So we just have a index buffer right here, one buffer to hold the index, right? Yes, because we're sending that phasor to. Are we sending to buffer? IXB. Sorry, I have to remind myself what we do. Well, we'll go down here and see what happens. So the IX synth is sending. Yes, it needs to read through the buffer. I'm sorry, right? Yeah. So that buffer just happens to be. Is it 0 to 1? Why do we have a buffer in there? Buff frames. Ah, right. Okay. So I guess it just, really we can do any buff, but this buff just is to set our scale and our frames and stuff like that. So we're reading through the same length, and then buff frames. Yeah. So it's just a reference. That's all that is. So we don't have to make more than one of those. In fact, we could probably just get rid of that and use like one of the tracks or something like that. But since we did it that way, we'll just keep that in there. It's really just an empty buffer that holds this timing information, how many samples are in that buffer. So then the phasor is a number from 1 to 0 being multiplied and divided, etc., by those number of frames. So it's going to go through 0 to total number of frames in that buffer. And then and then it's sent out either a normalized signal or an indexer. So in fact, I don't want to confuse things, but we probably could have just done this by having the raw phasor come out. But since that's probably harder to do, this way it's fine. We just re-normalize it. We're kind of doing it twice. So in any case, so we have that buffer, and that's just a timing information, so we don't need to worry about that so much. But we have these buses, one that goes to an audio rate, and one that goes for control rate. We have two buses, right? Now, so all this is to say that if we want to do any kind of looping, we need an independent index, right? We need an independent cursor, if you will, per track, right? So we need an independent one, and then we can just jump to that little cursor and just have it run through, okay? Run through that one. And you'll notice in the finished version that's what you can do. You can just loop little bits, okay, if you look at the demo or something like that. Okay, so we have to do a couple things here. First of all, we have to do what we did with all these things. This sort of idea is to make several buses for each track. Okay, so we're going to do exactly the same thing we did up here. So instead of IXA bus, we'll just call it buses like that. Okay, and IXK buses. We have control buses and audio rate buses. And we're just going to make, again, we have to put it into a function if you're going to make multiple ones. We're going to make an array of them. Okay, right? And then we can just make that shorthand, that shortcut array formation. We're going to times exclamation point and then the number of tracks. So that will create an array of buses. And because this is in this function, these curly brackets, it will put a different audio bus in each slot of the array, so 8 of them. It'll make 8 audio buses, and the same thing here. We'll make 8 control buses. Okay. Exclamation point, number of tracks. Oops. Okay, and so let's evaluate that and see what happens. Okay, it seems to be fine. Well, we don't have this number of tracks, so we'll evaluate the whole thing. Oops, because what did I do? Maybe a mistake here. No, that's okay. Did I change something down here? Ah, right, because now it's we have this thing called buses and bikes buses and IK buses. But where do we use it here? It must be in one of these OSC defs, right? Because I can't find IX bus, right? Easy way to do this, that's my guess anyways, is just do a search. We'll go do find, and we'll do IXA bus, and see next one. No, IXA buses. Okay, well, I'll spare you the troubleshooting this time. Just me being silly, I didn't boot the server, that's all. And if it the server's not booted, it doesn't know what s.sample rate is, so it's just throwing an error. Just a silly mistake. So that is fine. And if I go here and just close this fine so I don't have this annoying highlighting. If I just evaluate that variable, you see that it's 16, 17, 18, 19. There's all these buses allocated. Okay, so now we have an additional bus per track. Okay, and then let's make a separate master kind of master bus. So that will be like the main cursor that keeps everything synced up. So we'll still have that. And I guess we can include it in here. And I think in my example code here, in this code, I included, but that sort of just adds a little bit of addition and subtraction that complicates things a little bit. So I'm going to try something else, and it might not work. I might have to go back to including it. But let's see what happens if we create a separate bus, and we'll just say I just guess MIX bus. No, that looks like mix. So IX, we'll just call it main. IX, A bus, and then a main IX K bus. A bit confusing. That's okay. And then we're just going to make it just like here, just one instance of it. So one bus dot audio. Can't see S, and then one channel like that, and then same here. We'll just copy that, and this will be dot control. I'm pretty sure it's the same argument, so we'll just double check. Yeah, number of channels 1. Okay, so we have a main IXA bus and we have a main IXK bus. So that's the main cursor going. And then we have IXA buses and IXK buses. Okay, so we now have two options. We have the main cursor that's going to sync us all together. And then we have a separate bus for each of the indexes for each track. Okay, so just bear with me. We'll get through this, and maybe you'll see how things work a little bit as we go on. All right. So here, the IX synth, remember, is just this one synth we started, and it's just that one buff index synth def, and so it's just going to send that phaser to this one thing. So we still want that, except we're gonna change this to the main, right, IXA bus. We called it IX bus. What is that? Because I don't want to confuse things too much. IXK bus, IXA bus. I guess we just called it IX bus. That's fine. So the main IXA bus. I'm just a little worried here that. Yeah, hopefully that's okay. Sorry. So, yeah, so let's just make sure we're not screwing a bunch of things up here. Right, okay, so when we get our index, we have to correct this IXK bus here too. So why is this IX bus? Because I guess I just never changed that. That's odd. Well, I think we'll be okay. IXK buses, IXA buses. So this should be the main IX IXK bus. Right? Okay. So we're going to start it's the same as we had before. We're going to start this IX synth. We're going to use this buffer for the information. We're going to send it to this audio bus, this main IXA bus, and then we're going to send the control information to this main IXK bus. Okay, and it's going to be this IX group. Okay. Now, in addition to that, we're going to start a separate buff index synth for each of the tracks. Okay, so let's go ahead and do that. And we'll just copy this right now because it's going to be more or less the same. But we're going to pop it into this number of tracks too. So if you recall, we have 8 record synths and 8 play synths running, and then we're just turning them kind of on and off using our OSC defs. So we'll also have 8 IX synths running as well. So each track has its own indexing, a separate that you can switch in and out of. Okay, so IX synths IX, because remember up there we made an array. Did we make an array? We have to make an array here. We'll have to do this. We'll copy this. So we have these empty arrays to hold the synths, record synths, play synths, but we need an array of index synths as well. So we'll paste that in there, and we'll call them IX synths. Okay, and it's just going to create an empty array with a number of tracks slots in it. Yeah, so 8 in this case. IX synths IX. So this for loop is going to run through, and it's going to create a synth for each slot of this IX synths array. And the synths are going to be this buff index, and that's the one that just sends that phasor out to the different buses. Let me shrink this a little bit so we can see everything on one line. And the buffer is going to be now, instead, it's going to be this, no, this is just for timing information, so we can keep that. The audio bus instead, though, is going to be, let's just remember the name. It's going to be IXA buses. So IXA buses with the ES. Okay, and then it's going to be the corresponding one for the track, so IX. So if it's a for loop, it's running 0, and then it comes back in 1, IX is 2, IX is 3, right? So at IX 0, it's going to fill this IX synth slot 0 with a synth, and that's going to be writing this phasor to IXA buses 0 and the control bus 0 as well. So it's IXK buses 0. Oh, IX, sorry. But if IX happens to be 0, then it sends it to 0. Okay? So there. So then it's going to create these synths. So a separate index for each track now as well. And sending to these separate buses that we can grab for. Okay, IX group. Good. Okay, so that's good. So now we have something for each one now. Now what we need to do is we need to just go over these. I'm just going to go over all these OSC defs and make sure they're copacetic. And then I'm just going to create another OSC def so that we can decide to switch to this other index and do this looping thing. Okay. So let's just say I think the buffer play and buffer record a synth def. Sorry, the OSC def get index. So basically, we're going to get this. This is still just going to be the main index. This OSC def is just going to get, remember, to sync everyone together, we're just going to get that main index information right now. Okay. This is the reason I kept them in the same one. So it looks like I am going to have to keep them in the same one and do a little bit of confusing math. Okay, so sorry to go one direction and then kind of backtrack a little bit, but just bear with me here. So all I've discovered here is when we get index, if we want to put like a track number, then we can get the index information from that particular track number. Okay. However, with just one digit, we can, you know what? Maybe, sorry, I'm changing my mind here. Maybe we can just use an if statement. So why don't we do that? We'll do an if statement as well. Okay. So the idea right now is we just had the one index, right? So we don't need a argument here at all. We're just going to get this IX bus. We're going to get remember we had to write this whole function. So we're going to get that value of whatever that is in that bus currently. And remember that's being updated constantly. And then we're going to send it back to processing that particular value. So it just moves forward our index on demand, right? So processing asks for it, sends this message, asks us to send me the current value of the index, and it receives it, and then it moves that cursor forward. Okay. Now, if we want to do it per track, we can do it, but we just have to add the message in there, right? So arg message msg. All right, and we're going to create a var too, and we'll say tr track, and we'll just do it a little bit differently here. We'll just do it on the same line. We'll say track equals msg 1 dot as integer. Okay, so that's going to grab the track number from the message we send and then update this thing. So then what we'll do is we'll just send it to this ix ix sense, is that? Let's see. Oh, it's the IXK buses, right? So IXK buses. Okay, and then it's going to be track dot get. Okay, right? So right. So IXK buses track dot get, and it'll still be this, except it's gonna grab that particular from that particular bus. Okay, so we created an array of control buses, one for each track, and it's just going to grab that particular track's bus value and then send it back to processing. Now, of course, we need to also send to processing the track as well, right? So we're going to have the track and the value, so it knows which track to update as well. Okay, so let's put that information in there. So we'll put 3 bits of information. It'll be the TRK, and it'll be the val as float. So now when we send it back to processing, we're going to have to alter that, and we'll do that in the next video. All right, so that's going to change. It's going to send back. It's going to grab for the particular track and send it back. Now, this is where we run into an issue because we also have that main cursor. That's the main one that's synced, and that's the one we want to use all the time. Remember, we created an array of them that was just the number of tracks as audio buses and control buses, so you can send that phaser information there. And we made a separate synth here for each of those, so they each have their own possibility of having their own cursor. But also we have a main one too for everyone to sync, this main IXA bus and this main IXK bus. And we have a separate synth here, IX synth, that we created, so that that's our main, so maybe we should call this, well, let's just leave it IX synth for now. But you understand, it's the main one, hopefully, right? That's the syncing cursor. Now, so what we have to do is we have to have a way of grabbing that information as well. So this OSC def here, the first one we have here, get index, is getting one of the indexes. We have a way to get the individual ones for each track, but we need a way to get the main. So maybe we can just agree that we're going to send a certain kind of message through here, and then we'll just use an if statement to then set that one. Okay, so what we'll say is let's just say we'll do something like I mean, it could be anything. It could be well, since we'll just keep it an integer. Okay, so we'll just say 99, for example. Okay, so we'll just arbitrarily assign 99, the number 99, and hopefully we won't ever have more than that many tracks. We'll assign the number 99 to be the main one. Okay, so if the track information comes in as 0 through 8, it's going to be the individual tracks, but if it comes in as 99, then it'll be the main one. Okay, so, and then we'll have to change that on the processing side. Okay, so let's pop that in here, and I hope you remember the way if statements work here, the syntax. It's pretty similar. It's just we have if, and then the condition, then the comma, and then 2 functions, but you'll see. So if track is equal to 99, okay, then that's a comma, and then you have these the condition, the result in a thing. Then we do this, except we set a different thing here. Okay, well, let's see. I'm just going to copy this first, okay? We don't need the colon. Okay, so this is if it's true, and then I'll just close that with that curly bracket there, okay? And then I'll put a comma because the next set of curly brackets is if it's false, okay? So basically, real quick, let's just show you the syntax is if, and then condition, comma, function for true, function for false, okay? So if that's true, run this. If it's false, run that, okay? Hope that's clear enough. All right, so if track is equal to 99, then we're going to run this, which is not IX, but remember we said IX bus. Oh, sorry. No, sorry. It's the main IX K bus. That's the one, right? Because this is for the index, so we're going to grab the control data. Okay, so main IX K bus. And then it's not an array, so we just get rid of that. Okay, dot get. Okay, and then with argval. And we might as well be consistent in sending. We can either do track because it'll be 99 because it has to be true. Track has to be 99. So we can just do that. We can just leave it and send the track and then send the value as float because it'll send back 99. And we just have to remember on the processing side to parse for that 99. Okay. All right. So it's going to get the main bus now, and then comma is now for the if it's not true. So we do have to put this in the not true bit. Okay. So if it's not true, if it's not 99 or it's any other one, then we're going to run the normal IX bus here. Okay. And then that whole thing goes into that bit right there. And then we have to close it with that, close the if statement there. And you see that turns red too. Okay, let me make this a little bit more clear by using some hard returns. So if track is equal to 99, then that's true. Then we're going to get the value from the main bus, the main control bus, right? Okay, which is the cursor that's going to sync everything. If not, we're going to get the individual buses 0 through 7. All right, so that we can get individual cursors from that. All right, and that's this. Remember OSC def, and then I just put that so it closes the if there. It's a little bit more clear. So, and we don't need this comma. Sorry, that might throw an error. So this, remember, the get index is just a on-demand service from processing. Processing asks for the index. It sends it back to processing through these send messages, and it that uses that as a sync to advance the little cursor. So in this enhanced version, we're going to tell it which track to send us, but we're going to use a special tag 99 to send us back the main thing, so we can generate the main cursor. All right. So that's fixed there. Let's just look through other OSC defs and see if it impacts this changed up cursor. So we're looking for any kind of index thing. These are just turning on setting the gate, the plays and record sense. Same here. Play is doing that. The pause is doing that. The waveform might be no, but it's grabbing this function waveform. So we have to look at the waveform function and see if it has anything to do with anything, but I don't think so. It's just grabbing the waveform from the play, the record, the tracks buffers, the record play buffers, the actual where the sound is held, but it's not impacting on the index. So it seems like that's okay. Okay, good. Now, finally, the last thing we have to do is to create a function. So the goal here, after all that, is really to be able to drag and grab one little loop, or make a little loop and then have it repeat, do that kind of thing. Okay. And so we have to do a couple things. What we're going to do is, and let me just walk through this, just talk you through this, and then we'll implement it, okay, in a OSC def. But just manually, forgetting about the fact that it's an OSC def, the steps we need to take is one, let me make a little list here, even steps to take. Okay, one, Well, let's just review again. I know I did this earlier, but let's review again what happens to the play. We're talking about the play buff, right? So the play buff is controlled by an index that's coming in this index bus. It's just reading a value from a bus, and it's just making that index, that little motor that pushes it along the read head. It's like the play head of a tape recorder. It's kind of inverse, right? The tape moves along the play head, but let's imagine if we stretched a giant, and you might not even relate to this at all because it's all digital now. I don't know if my listeners remember tapes at all, but look it up if you don't know what a tape is. But imagine if you took a cassette tape and just stretched it, just had a friend hold it at one end and then run down the street, and you hold it at the other end, and then someone walked along with the playhead against the tape. Okay, this is the thing that is the walker, is the guy that moves the playhead along, and it's going to play back wherever you are. All right. So, and the way we're getting this is normally we'd stick like a phaser, we'd stick something that just moves it along like a little robot, but in fact we're grabbing it from a bus. Okay, so just again one level removed. Okay, we're grabbing it from this bus, and we're able to do that because we have this other synth, this buff index, is writing into that bus. Okay, it's writing out into this audio bus, or also control bus. Okay, the reason we have two buses, of course, is that one is to control our audio objects, the record, the buff write and buff read, and the other one is to control other things, for example, the cursor in our processing object. Okay, but we just need a control rate object for that. In fact, the frame rate is probably even slower than the control rate here, so we need it even less. Okay, and so what are we sending? We're sending this phaser object that has this kind of just math that's done to it, so that it's actually reading from 0 to the end of the number of frames in that particular buffer, based on that buffer's length. And then also we're normalizing we're renormalizing. So phaser starts out at 0 to 1. We've changed it to go to the thing, but we're renormalizing it, sending it back to 0 to 1, which seems a bit convoluted, but it's probably easier to do than trying to extract the 0 to 1 originally out of that. Okay, so you're right. So we have an index, a norm, a 0 to 1 that's going out to our control bus. So that's going 0 to 1. All right. So in the playback, we send that index thing controlled by this buff index synth stuff. But you notice we have a speed control, an argument for speed. We have an argument for start and end too. Okay. And then we have the A bus, K bus. We can switch which bus it's being read from, right? So you can actually grab your index from a different bus, from a different control bus. You can send the index out to a different control bus, and you can the play can read from a different index, is this index bus, right? Okay. So what we've done is we created all these buses to send the individual different indexes to, but we can control that index to start and end at different points, all right? And we can read from a different index bus. Okay, so those are the two things we do. So the first step really is to I'm just trying to think of the order that we want to do it in. So we probably want to set up the indexing bus first, and then switch the play head over to that bus. Okay, so first we'll do one step will be to set the appropriate, or the track index synth, and so we need to do start and end time and end time. Okay, and is there anything else? I mean, I guess eventually we'll do speed, but I'm not going to put speed in there just yet. That could be something that you can do independently and play with that. So start and end time, and it's still writing out to the same bus because we're just going to keep it out there. So yeah, just start and end time. So we're going to start set the start and end time. Okay, so let's just start our OSC def, and we'll add it one step at a time. All right, I'll just do it under here. I'll make an OSC def. def, and I'll call it set index, set idx, and then create a OSC name for it, which will be set idx, the same. Okay, and that OSC def. All right, and I imagine we'll still need to, we'll need the arg message, and we'll need to get the track too. So var track equals message 1 dot as integer. And we might have to do something similar to this if then statement, since we decided to go that direction. And what we're going to do is we're going to set, what are we going to set? We're going to set the synth. We're going to set the particular synth. Yeah, so, well, we're not going to let's not mess with the main cursor. We're just going to leave it alone. And you can do that on, if you have a side project that you want to do. I mean, if you have an enhancement that you want to do to this, you can change the main cursor. But we'll just leave that run so we can pop back and forth to it. That'll always be this constant that's going. All right, we'll make that decision. But if we want to set the individual synths end and start time to make it like a little loop, we're going to grab one of these index synths based on the track number, and then we're going to set the start and stop time, which are arguments we made. So we're going to start and end, actually. So we have to make sure we use end and not stop. Okay, so we're going to grab set index. It's going to go tilde ix synth. Is it ix synths? ix synths. Yeah, okay. ix synths, and it'll be the track. So that particular ix synth, and we're going to do that set. And what are we going to set? We're going to set the start, and I'll just leave that blank for now, and the end. Right, that's what I called it, right? Start argument and the end argument, right? Start and end, yep. Okay. Now, what are we going to set those to? Good question. So I guess we need a start and end time too as well. So we need plenty of things come in the message. And we have to kind of remember that they are the particular items. We have to remember which number they come in. Okay, let me cheat and look at how I set it up. Set index. We have track number, start, end, and then speed. So I did add speed. So we might as well do that. Track number. So we'll set up variables the old-fashioned way, and we'll just declare them here and then set them up later. Okay. So track start, end, speed. Okay, start, end, SPD. Okay, and then we'll say track equals message 1 is integer, and we'll just keep going. We'll say start equals message 2 dot s. We're going to make it a float, right? And then end equals same thing, but message 3 as float, and then speed equals message 4 dot as float. Okay, so those are the four messages we're looking for, 4 bits of data that follow the set IDX. We have to put a track number, a start time, end time, and a speed. Okay, now how do I deal with, because there's some kind of conversion needs to happen, right? Oh, maybe I already do it in the synth def. I think I do. So I think it's a normalized already here. So we're going to go from 0 to 1. Yeah, so the phaser is going to go from end times the buff frames, right? So start, it's times the buff frame. So if it's at 0.5, for example, halfway through, it will grab times the buff number of frames. It'll grab half that amount of frames. So start half that amount. And then if I want to go to the 0.6, then if end is 0.6, it'll go to that point in the buff frames. Okay, so that's already done for us. So we just have to make sure we send a kind of percentage level, which we can calculate in processing. So that's a processing side thing. So we're good to go here, more or less. We're going to set these things, And so then start is going to be set to start. Okay, that's set through processing, and end is going to be set to end, and then speed is going to be set to speed, and I think that's what I called it. Well, let's double check here. Speed, SPD. Yep. Okay, so that's the what's happening. It's going to set all that stuff, and speed. Places. All right. Okay. So that was a long part one. I guess this list isn't actually that helpful, but part two really is to then set the play synth since index to the individual, I guess, track index. Not only are this is not helpful, the language is so convoluted, I'm not sure you understand what I mean. But let me let me show you. So we have these play synths, right? And they are reading from this IXA bus, right? They're reading that phasor information from a particular bus. So if you wanted to change to that particular index that we set, that's only reading from a certain start to end time, like a little loop, right? We have to switch, switching the railroad tracks. We have to switch it over to that to read from that bus instead of the main bus, right? So that's why we made the distinction, okay? So we're going to have to do this little 99 thing. We'll just keep it that way as well, okay? So we're going to set the IX synths, the index synth, to only go from this start time to this end time and at that speed. So instead of the main one will always be going from, the beginning of the buffer to the end of buffer. This might be going from one part of the buffer to another part of the buffer, okay, and at a certain speed, okay. But then we have to just do that train track switch over. So we have to then set, and it's the track number is the same, so that's why it's good to keep a consistent track number. We have to set the play synths, and then it's going to be track. So if we send as a track, track 2, or the 2th, which is the third track 3, or the 2th track, then it's going to set that play synths 3 or 2, sorry, and dot set, and it's going to set the does it have an A bus and K bus? No, it's just the A bus, right? It's just a bus, period. Right? We just say bus, index bus, yeah. So IX bus. So it's going to set the IX bus. Sorry. IDX bus. I knew there was more letters than that. IDX bus. Index the X bus. And it's going to set that to this bus. So IX synths. Sorry. It's can be a bit confusing. I'm confusing myself now. But remember, we're changing that synth because we want to change the start and end time of the speed. But now we're going to change it. But it's automatically writing out to these IXA buses and IXK buses. So that's actually the bus we want to use to set the index, the play synth to that index bus. Okay. So that means we have to set the IXA buses, and then it's going to be track, which of course itself is an array. So it's going to grab the index now from this track bus instead of the main bus. Okay. All right. But we want a way to set it back to the main bus. So we can write a separate OSC def and do that, but let's just stick it all in the same one, and we'll just use that 99 track. Again, that 99 trick. Okay. So we'll only do this if it's not 99. Okay, so we'll do the same thing. So we'll say if the track equals 99, okay, then we will do a we don't need to set a synth, but we have to set this play synths back to it. Okay, so we're going to copy that, and we'll say we'll set the play synths track number IDX bus back to the main IXA bus. I think that's what we called it, the main IXA bus. Good. Okay. So that's what's going to happen if it's 99. All right. And then we don't actually need that semicolon because there's just one thing, but we do need a comma between the two. If yes, then do this. If no, then if false, then do that. So that's if true, it runs whatever's in these two curly brackets. But if it's false, it runs whatever's in these two curly brackets. So we'll put one at the begin that and one below that. Okay, so first it will, then if it's not 99, so it's 0 through 7, it'll set the synth first. It'll set the IX synth first to a different start, end time, and speed, and then it'll switch the railroad track from the play synth to this actual synth that's only running from this to that. Okay, so hopefully that's kind of clear. And why this is not the same, why it's not IX synths here, is because this IX synth is writing into this bus. So we're reading, the play synth is then reading from this bus. Okay, that's writing into that index, right? So now the play synth has switched tracks and now is reading this index from that start time to that end time. And it's just going over and over again, okay? But if we want to switch it back to the main one, then we say go to track 99, and it's just going to use that as a tag and then switch it back to this main bus, which is going from the beginning of the buffer to the end of the buffer, so all the way through, okay? And then we have to end our if statement there with that. Be careful to do that, and then a semicolon there. So if I select all, and go to edit, auto indent line or region, it'll push everything the way it should be, okay? So this is if, this is the condition, and this between these two curly brackets is true, between these two curly brackets is false, okay? And that's, if it's 99, then it's going to go back to the main one. Otherwise, it's going to run those things, okay? So I think pretty much there we have our set index sorted. So I think that's everything. We don't really get to test this out yet because we have to modify all the processing side. This is a little bit delayed gratification. We just have to trust that we did it right. And it opens up the door to a lot of potential errors, but we'll cross those bridges when we come to them. Let's end this video now, and then the next one we'll deal with the processing side. And then after that's all sorted, then we can test and see if we do anything wrong. So there might be a little bit of troubleshooting in the next video in case we made any mistakes here. So let me save that, and let me at least just send it and see if it runs. Seems to be fine, so there's no just like typos or anything like that. Okay, that was pretty complex, but you know, I'm sure you can handle it by now. We've been through so much together. I said the last 2D, a couple tutorials ago, that 2D, two-dimensional array was the worst of the bunch. This is probably a pretty close second. But you know, like I said before, just watch it a couple times. If it's a bit confusing, I think the way I presented it might have been slightly confusing, but it's simple enough. Basically, you just have to understand the main principles of how these things work, which is simply that we have a very simply a record and a play. It's like, again, it's like that guy walking with that playhead. One is walking with a record. One guy's walking with a record head, and one guy's walking with his playhead along this tape. If we I'm trying to extend my metaphor here, and I'm running into problems extending the metaphor. So I guess I talked about switching railroad tracks. So I guess maybe the play guy, there's another. So let's pretend this. So if this guy, the main guy, is walking along the play head, and he walks, with the play head along the tape, and then somehow magically goes back to the beginning, walks along with it, and disappears back into the thing. Or maybe he's walking in a loop, and then he gets back to the beginning, starts again. Maybe he's walking in a circle. So if it's a long play tape, the guy's walking along with the playhead and then walking along, so he just plays that long loop over and over again. Let's say you have another guy walking inside here, and he's just walking along one part of the tape like that, and then when you give him a signal, he pushes his playhead against that and just walks along and just plays this way. And the other guy who's walking the whole circle just picks up his playhead, so he's not actually playing anything. He just picks it up, but he's still walking that. He's still walking around. He's just, his playhead's not touching the tape. And this guy's just walking here, back and forth, like this, and then back, and then like that. And he is now touching the thing. So that kind of works as a metaphor. So we're walking along this playhead and that. So this is what this does. Then the set index basically says, if we changed it to 0 through 7, then we're going to actually first set we set the trajectory of the one guy walking just in a little part. We give him a bit of information to say, okay, walk from this part and end there, and then just repeat. He's going like that. Or he might say, walk from here, so there's no actual circle here, but let's just picture a circle here. Not the best visual. Maybe I should put some animations in here. But anyways, he walks, okay, let's say walk from this part to this part. So he walks. And so that's what this does. It sets that second walker to the start and end times. And then this is the switch part. This is where it says, the main dude who's walking all the way around says, okay, you lift up your playhead so you're not playing back. And you, the local guy who's doing the little loop, you put down your playhead. So this is what this does. It says the play synth is going to be set to the bus, which is that particular individual track bus that has now this start and end time. Okay. Now, if we get a 99, then it says, okay, let's switch places again. The guy walking his little loop, now it's going to lift up his playhead. And then the guy walking the big loop is going to set down his playhead. All right. And it's going to now play the whole thing based on the main cursor, which syncs everyone up. Okay. Phew. So hopefully that little picture, even though there's no actual circle there, you kind of understood that and maybe helps things along. But good luck with that. And then the next time we will go to the processing side and make all the little changes that we need to make. So there's few bits of data here that we have to just refresh our memories. Like we made some changes. We have to send some messages now. For example, the get index with a track number, and then we have to start up a whole set index kind of thing. Okay. All right. Well, good luck. And the next video, we'll tackle the processing side.